All right, let's look at number 20 real quick. Number 20 says, you are fighting against a monster trying to get through a partially open door. So here's our partially open door. Here's the monster pushing this way. Here's you pushing this way. You push with 223 newtons. We don't know how much force the monster pushes with, but we know the door doesn't move. So this is a typical torque problem in equilibrium. That means it's not moving. So we write torque 1 is equal to torque total is equal to torque 1, 2, and 3. Torque 1, torque 2, torque 3. We choose this one to be our pivot point because it's easiest. I'm not really concerned about what's happening at the hinge, so we're going to call the hinge the pivot. So we know that's going to be 0, and we know that since the door does not move, the torque total is going to be 0. So 0 is equal to, I got rid of torque 1, torque 2 plus torque 3. Now I didn't give you torque 2 or torque 3, so we have to break this into what we do know, force 2, radius 2 plus force 3, radius 3. What do we know? No. We don't know the monster's force, but we do know the monster's radius. We don't know, we do know what our force is, and we do know what this radius is. And you always measure from the pivot. Always measure from the pivot. And I give you this distance here. I give you that distance here, and again, 0.56, I made sure to say it is from the hinge side. It's not from the door knob, it's from the hinge. So just fill this out and, rearrange the equation here. Subtract force 3, radius 3. That could be a negative over here. And then divide each side by radius 2. You have force 2 is equal to this. Plug the numbers in, and you have 558 newtons. It could be negative. But as we see, if this is pushing this way, it's causing a counterclockwise rotation, so no matter what the sign is, you're going to call that 558. Change it. Let's look at problems 21 and 22 real quick. Problem 21 says you have a handle on a fishing rod. So here's your fishing rod. The fish is pulling down on it this way. It's a torque problem. It doesn't move, so we're going to let it equal 0. Torque 1 will be the pivot point. We'll call this as this fishing rod. It's hooked into your kind of hip, and here's a fish on the end of the pole. So we're going to say that this is our pivot point, so we're going to let that equal 0 because its radius is going to be 0. So simply we have torque 2 and torque 3 that we got to find out. So I rewrote this as 0 is equal to force 2, radius 2 plus force 3, radius 3. Again, this is your hands. Your hands are pulling up this way. This fish is pushing down this way. We don't know how hard you have to pull up. We don't know what this force is, but we do know its radius is 0.35 meters from the pivot point, not from the tip of the rod. And then force 3, radius 3, here's the radius 3, 4.2 meters, and the force 3 is 65 newtons. So I just rearranged this over here. I put the numbers in my calculator without showing them to see if you know what to do, and I got 780 newtons. He's pulling in this direction. Since it's going to cause a clockwise rotation, it's technically negative 780 newtons. Let's look at problem number 22. You have a board that's on a step. I made a mistake. I did not say that this person weighed 78 newtons, but add that to your problem, 78 newtons. So here it is on a step, and we're pulling up this way. So this is torque 3. This person's weight is downward, so that is torque 2. So let's see how this works out. Torque total is equal to torque 1 plus torque 2 plus torque 3. So of course we let that equal 0. Let's choose the stair to be the pivot point. Why? Because we're really just interested in what this force is right now. So let this be the pivot point instead of this. So I let torque 1 become 0. So we have torque 2 plus torque 3. It's what you've been seeing all along. You need to break this down to force 2, radius 2 plus force 3, radius 3. We do know what this person's force is really because it's mass times gravity times radius. We know all these things. We don't know how much force you need to pull up with. So force 3 is the unknown variable. We do know radius 3. There is a little problem here though. When I originally set this up, I was measuring 1.1 meters from where you're pulling up. But if this is the pivot point, this is the radius. You always measure from the pivot point to the torque. So actually, torque 2's radius is 2.7, not 1.1. Okay, this is actually unimportant. Okay, I'm just interested in what this radius from here to here is, and the radius from the pivot to the end of the board. Again, we don't measure from these other spots. We chose this to be the pivot. We measure here, and we measure here. So what does that look like when we rearrange this equation? Mass 2, gravity, radius 2. Our radius 2 is 2.7 meters. This is 2.7 meters. And our radius 3 is 3.8 meters. And the answer is 543. Since it's going up and it's causing a positive rotation because it's going counterclockwise, this is a positive number. And if you want to know what this force is, the force of the step, this person has a weight of 780 newtons. 78 times 9.8 is about 780. If this is 543, then this has got to be about 137 over here. Because 137 plus 543 is going to be approximately 780, right? 543, 643. No, I did that wrong. Let's see. On 780 minus 543, and this is going to be $237, right? It's going to be 237 newtons upwards because these two are literally holding up this person.